Good morning, sir. I am Michelle Flores Colongon, and this is my video creation of how I create the Python program for my final exam of OOP. The final two. So the question is to create a class called matrix containing the init that initialize the number of rows and number of columns of a new matrix object. So the class has the following information. So number one, number of rows of matrix. Number two, number of columns of matrix. Three elements of matrix in the form of 2D array. So the matrix class has methods for each of the following. So 1, get the number of rows. So 2, get the number of columns. 3, set the elements of the matrix given a position of I and G. So adding two matrices, if the matrices are not addable, matrices cannot be added, will be displayed. So number 5 is multiplying the two matrices. So Python matrix. Here we'll discuss the different ways how we can form a matrix using Python. Within tutorial, we will also discuss the various operations that can be performed on a matrix. We will also cover the external module of NumPy to form the matrix and its operation in Python. So what is the matrix? A matrix is a collection of numbers arranged in a rectangular array in rows and columns. So in the fields of engineering, physics, statistics, and graphics, matrices are widely used to express picture, rotations, and other types of transformations. The matrix is referred to as an m by n matrix. So denote by the symbol of m, x, and n if there are many rows and columns with a simple matrix using the Python. So creating matrix with a list of lists. So here we're going to create the matrix using the problem number 2. So I create the codes into the decoder of Python. So I use the Python 3.7. Class matrix, define the init, self, n, and m. So self matrix is equals to self, get matrix, and n and m. So we define get matrix, self, and m. So number is equals to 1. Matrix is none of the G in range, so M is for I in range N. So for I in range is len to matrix. For G in a range of len matrix is matrix I, G is equals to number. So number plus is equals to 1. So return matrix. Define get readable matrix strings, self matrix strings. So this is this list. So for row in a matrix, strings append strings row, return the aim, join the strings. So define strings self, return the self, and get the readable matrix string self matrix. So define the len self, return len self matrix, define get item, so self and item, then return self matrix item. So next one is the define get element. So we use the element, so the self is I and G. So return self matrix. I is -1, G -1. So define set element self I G element. So the self matrix I is -1 and G is -1 is equals to element. So define transpose self matrix, return list I for I in zip matrix. So define get transpose self, return self, get readable matrix string self transpose self matrix, define do transpose self. So self matrix is equals to self transpose self matrix. So the next is define multiply self matrix. So result is equals to 0 for G in a range of len matrix I for I in a range of Line self-matrix, for I in a range in Line self-matrix. So for G is a range length matrix, so for K in range length matrix, result IG is equals positive equals self matrix IK times matrix PG returns result. So define the get multiply self matrix return self get readable matrix string self multiply matrix. So define multiply self other if is instance others matrix return self get readable matrix string. So self multiply other, so it is returned to self get readable matrix strings the num times other for num in row for row in self matrix. So this is the information. So M1 is equals to matrix 2 3 print M1. So then the print M1 get element 2 to 2. So M1 set element 2 2 is negative 10. Print M1 get transpose. So the print M1 do transpose print M1. So M2 is equals to matrix 2 3 print M2. For the print M2 get multiply M1 print M2 times M1 print M1 times 3. So this is the final codes. And I run this code, and this is the output of the second final problem. Thank you. This is the algorithm of my final two in OOP. The algorithm is step 1, start. Step 2, get the number of rows. Step 3, get the number of columns. Step 4, set the elements of the matrix of given position I and G. So the step 5, adding two matrices. If the matrices are not addable, matrices cannot be added, will be displayed. So step 6, multiplying the two matrices. Then the last one is step 7, stop. So this is my flow chart that I create. Start, read rows and columns of matrix, then read elements of matrix. I use the I is equals to 0 and I plus plus. So I is less than C. Then G is equals to 0. G is less than to R. G plus plus. Next is at I, G is equals to E, G and I. So from the frame resultant transpose matrix, then stop. That's all. This is my final output of my final exam. Thank you and get blessed.